Thank you, Maven team, for the invitation and giving the opportunity for me to be part of this event. What an event and what a crowd, right? So it's inspiring for me to see how the momentum is being built, how everyone is here for a purpose, purpose in terms of being engineer, purpose to understand what is there as part of the AI era for them, what transformation is expected from each one of us or each one of you. What a great evening. Thank you, everyone. Uh, let me start. The panel discussion, and let me start by saying, as we understand, semiconductor, is at the center of AI, right? Whether we talk about the accelerators, whether we talk about the GPUs, NPUs, whether we talk about the workloads, everything is centered around semiconductor, right? So it's become very exciting to see now and in future how the role of a typical VLSI engineer is going to evolve. And of course, in the morning we had a certain interesting discussion from Shiva, from Dr. Vijay. I'm personally getting a little worried, in terms of the kind of skill set, the kind of capabilities an engineer would need. I won't say to survive, but to excel in this competitive world of AI, because looks like the primary competency of one of the must-have skill is more towards expressing oneself, right, or himself, because everything appears to be going towards a prompt engineering, the way Dr. Vijay spoke about genetic AI, right? So I'm worried, and I'm going to put this expression as a very key term, as a learning from this whole forum, and this is something which I really like to focus, not only for me, but for the rest of the folks, who are part of my team, that expressing oneself is very important. If one has to survive or one has to excel, in the current era of AI. So, welcome everyone. I'm Resty, and today I'm your moderator, for this interesting topic panel discussion on AI-driven chip design and how roles of engineers will evolve. And we have distinguished panelists from the various fields. Like we have entrepreneur, we have folks who are focusing on flows methodologies, who are folks who are too deep into the technical aspect of chip design and who are being using AI to how to accelerate and how to optimize and how to make sure the best out of the given spec can be achieved, at the end of the day on a silicon, right? So let's start with a quick introduction from our panel. I'll request to start with Pradeep. And Pradeep, when we do so, please also give a brief about your organization, your role, and where exactly, if you can quote one example of AI which you already started using or your organization have started using, that will be of great help, for all of us. Yes, we'll start with you, Pradeep.
Thank you, Resty, for moderating this session. And thanks, Maven Silicon, for this opportunity. Before I start, I have one request for Siva. You have a very good curriculum. Only thing is, wish list is please add tape out experience. Something, nobody is doing that. If you can add that, it will complete the loop actually, So that's a request from my side. Thank you. Okay, so answering to, I work for a company called Ausdia. We are a EDA company, and we mainly focus on timing constraints from the RTL to GDS2. Okay, so whatever AI we are doing for first silicons, success and everything, we are trying to do at the timing constraints level, because that is a main thing. It's a seed basically from the RTL before synthesis or before STA or before PD or before final sign off. So that's where our company is focused on the timing constraints. And to answer like what does AI is required actually for our tool? Yes, not as a just a just a selling point, as a marketing point, saying that Ausdia is also having a AI related. Where we see as a value addition is, so for example, we in our tool, if somebody has missed a clock definition, we kind of print an error. Actually, you have missed a definition. Now an engineer wants to go open the manual actually and then understand. So here we are trying to work on the co-pilot actually, which will help the engineer. Okay, so this is what actually you have to do, and this is a constraints you are missing, and they will help. So here the thing is, like, we are trying to help the productivity of the engineer. So that's where we are bringing in AI capability within the tool. Okay, and so coming about, one of the thing is like, it's scary actually, right? If engineers will think I don't have AI knowledge, can I survive in this industry? So it's not like that. Basics is always required. AI can give anything actually. If you don't have a VLSI basic, how do you know whatever the AI is given is correct or not? So for that, definitely the platform is required. Maven Silicon is already, teaching the students. That knowledge is compulsory. AI is just on top of it. Okay, so engineers' jobs are safe. I know these words are very sweet to all the ears, hearing this. So AI is just like, it's part of it basically. Like how Google came, right? We are going through that wave basically. So nothing to be scary. It's always, it's also good. And there is also a debate actually. Is it like semiconductor is powering AI or AI is powering a semiconductor? Because if you don't have a chip actually, right, how AI performs basically, right? And now the other thing is like, if you don't have AI technology, how you can integrate in semiconductor? It's actually the coexist. Both semiconductor and AI coexist actually. So with that, I just want to conclude my point. Thank you.
Hello everybody, this is Nitin Naik. I am founder and CEO of Blueberry Semiconductors. I have started my career as an average engineer from Tier 2 city of Nagpur. Okay, and after spending 10 years in product design, I entered into semiconductor in year 2000. So your entry into semiconductor is very important if your basics are clear. Okay, so when you are a beginner, you should focus on fundamentals of and basic of semiconductors. That is very important. So after working 10 to 12 years in different VLSI companies, I started my first venture, Orange Semiconductors. And after successful acquisition of Orange Semiconductors, this is my second venture, Blueberry Semiconductor, where we are providing engineering services to major product companies in India and abroad. We are having specialization in design verification, physical design, and mixed signal verification. Blueberry Semiconductors, established in 2017, completed 8 years, and we are having 160 plus member team in design verification, physical design, and mixed signal verification. Thank you.
Good evening, everyone. Firstly, I would like to thank Maven for this opportunity, and it's a wonderful initiative, sir, whatever you're doing here. So apart from just creating engineers, bringing in some of the industry experts and a lot of people all together under a common platform, it means a lot. I think we had very good keynote discussions today by most of the distinguished members here, and especially I like the way Wipro presented the agentic AI and the generative AI and what is the future and the complete orchestration framework. So it was very informative. So as far as our company is concerned, I am co-founder and director at PravegaSemi Private Limited, and we are a 170 engineers company, and we are expanding rapidly, primarily focusing in front-end design and verification, and we definitely have other back-end layouts, other services as well. As far as AI usage is concerned, we are also venturing into embedded AI of late. So we are investing, as it was rightly told by Shiv Kumar sir in today's keynote, the system software knowledge becomes very critical when integrating an AI. So what we have done is we have imported some boards from US, the latest Jetson board or the Beagle board, which is having a TDA 4VM TI chip with a MMA, which is going to run the deep learning accelerator, and we are trying to run some of the AI edge inference applications on that, such as traffic analysis or something like that. So that is from the system software solutions perspective. That is some initiative that we are taking. Apart from that, of course, we are encouraging our engineers to buy some of the subscriptions such as Cloud AI or Cursor Code or Cloud Code, and work with the coding platforms, which is like GitHub in collaboration with VS Code in collaboration with Copilot. So that is what I'm seeing is there is an acceleration where an engineer uploads the complete spec into the Copilot and is able to download the complete API, which we used to hand code earlier. And that is not something groundbreaking, right? So the engineer shouldn't be wasting time writing the fundamental basic building block. Rather, he can now focus on complete system level end customer usage, what is there, and he can focus on the customer use case scenarios and prove better prototypes or go with more coverage, functional coverage, when he is verifying or when he is working on the solution. So that is one major increment that we have seen in terms of AI implementation in our company. So apart from that, of course, the RTL team, the PD team, the DV team, they are continuously trying to use AI in their day-to-day basis in discovering issues, or in the simple example is a very small RTL design can be uploaded and it can figure out where is the CDC, where is the RDC, and how many clock domains are there, and it can automatically generate the constraints that is required. So which makes work very fast, very easy, and they can focus on much more complex tasks in their day-to-day life. So we plan to expand our horizons in AI. One good thing about AI is, as someone here told that AI is not going to take jobs. It's definitely true, because AI hallucinates, and it hallucinates when it shouldn't be hallucinating. So that is going to make it mandatory for human vigilance and human verification. So whatever AI is going to do or generate, it needs a second eye. And I don't think in near future, no intelligence will take over human intelligence so easily. So that is going to create more jobs, and we are going to make this world a better place by using the help of AI as a catalyst, as a backbone. I think the human beings are going to define a new world as a new industrial revolution of backed by AI. So that is the future I see with whatever is happening right now.
Sure.
Thank you.
Thank you.
My name is Raja Mahadevan. I work as a principal engineer at Synopsys. So I am sure that many of you know much more about Gen AI, Agentic AI, MCP, COT, or whatnot, because first time when I got to know about MCP, I learned it from a 19-year-old kid. Given my age, yeah, he is a kid. So I'm sure that you know better than me when it comes to AI. So I deploy solutions based on Gen AI. So I work in formal verification, and the Gen AI-based solutions that we provide generates assertions, and we do use our tools capability to process it and give a refined system log assertions, and customers can also add their complex assertions in the RAG, and it can be pulled in for verification. So that's about my current work, which I'm engaged in. I'm pretty much in Gen AI-based solutions.
Sure. Thank you, Raja. Yeah, Ravi.
Thanks, everyone. Thanks for giving this opportunity, first of all. Okay, so myself, Ravi, like basically I'm completely from the DV background. So I'm always only talk about the SVUVM right now. So you know, right, nowadays the AI is going to, what I see the positive point is that it's going to increase the efficiency is the first thing. The major things is going to increase the efficiency. In day-to-day life of the verifications, right, we struggle in the lots of things. the regressions and everything. So if you talk about this generative AI or the agentic AIs, right? It's both of these different AI techniques is going to definitely help in our day-to-day life and improve our efficiencies. Because see, when the AI will come into the like full phase, right? The major challenge from the DV side will be like you will get that design or anything right very fast. You will have the very short turnaround time for the RTL to the netlist and everything, and you need to be like very much sure about the verifications quality also at the same time. So at the same, that is coming as an opportunity for the verification engineer to use the generative AI or the agentic AI to improve the your efficiencies and get rid of all the redundancy work which currently we are doing in the day-to-day life, right? So that way I see it as an opportunity in the AI instead of like anybody AI is giving any something wrong to the market or industry.
Thank you, leaders, for the great insight and the self-introduction. So one thing which stands out here is whether it's entrepreneur, whether it's a technologist, whether somebody, who are core into the defining specs and architecture, AI is touching everyone, right? So there is no going back, as Dr. Vijay has said some time back, there is no going back. We need to adapt it. We need to see what's the best usage of the same can be done in the respective field. If you can touch base a little bit more in terms of how the various roles will evolve, right? If you can get a little bit more in depth. So let me start with you, Pradeep. Pradeep, you mentioned about specific on the physical designer or the static timing analysis engineers, right? So how do you see how these two particular jobs, who are responsible for closure on the PPAs and making sure the design meets the timing? So how do you see, how these two roles are expected to evolve, with the infusion of AI going forward?
So, so basically what's happening is now SOC design size is growing. So when an engineer can close one block, he's now closing 2-3 blocks basically, because even though we are like, Maven Silicon is training many people or any other training, but we still have a shortage of resource. Okay, so that's why each engineer is loaded with more blocks. So when it is with more blocks again, so it's kind of, there is always error prone actually. So that's where I see AI plays a very crucial role. Okay, so AI is what actually, like people are already doing Python script and Perl script actually for some automation, right? But AI can do much better if any company has their own model basically trained. So these 4 blocks when he closes actually, so he can focus on the very quality closure basically, rather than because, oh, okay, I have to close this, let me just, do something and then put some false path or multi-cycle path, just close this actually, right? So that affects PPA. He can close the block. When it goes to SOC, so there will not get a PPA. So that's where I see a lot of value in terms of, adopting the AI basically.
Sure. Yeah. Thank you, Pradeep. And the second critical element is, the typical blocks, what we discussed, at the start of this meeting. Like we spoke about accelerators, TPUs, GPUs, and other critical known blocks. So, Ravi, from your perspective, how critical is for engineers, to know in depth of this design element? Do you see this will lead to a lot of transformation wherein VLSI engineers, the folks who really do a design, the folks who really do a lot of integration at the top level, do you see the folks, the engineers are expected to know a very deep dive about these blocks?
Definitely. See, I can say that if let's assume that nowadays, right, AI is generating the test bench environment in a one click away, right? So where you can outperform the AI is the system level understanding. Until unless you don't have that one, the basic test bench generations or the design verifications, any of the tools can do right now in just a click away going forward in next 1 or 2 years, right? So the system level environment understanding is very, very much important, where the human brain can outperform the AI, right? Nowadays the new technology like the 2.5D ICs and the 3D ICs we are talking about, right? Where we don't have the much idea on the AIs for that particular data, because AI work on the previous data, the past data and all these things, right? So there, the engineers has to outperform the AI and work on the understanding the 3D IC chips, right? how exactly the system level scenarios you can verify in the 3D IC, the power related, the thermal related aspect, right? Which nobody can you can automatically generate from the AI tools and all.
Sure. Thank you, Ravi. How about the system architecture, right? The chip architecture. So if I can ask you, Rahul, what do you see how these roles are going to transform? Because uh, contextually, if you see, the AI will enable generating some code, right? But there'll be more and more need of folks who can define, as Shiva is saying, there'll be need of more and more folks who can define the system level architecture, who can define the complete, use cases and more. So how you see these roles are going to evolve?
I think traditionally from the system architecture perspective, all this while the parallel computation was focusing mostly on GPUs, and GPUs were workhorses or powerhouses which used to run gaming. Today, the same GPU is able to run a lot of parallel tasks, which is a bread and butter for running any AI software. So from the system architecture perspective, from the GPU, now it is traditionally transforming into NPU, TPU, or VPU, vector processing. So the parallel processing is going to be a very common thing from the system architecture. So this changes a whole lot of game, right? So all this while the software people, they were thinking of running something in sequence. Now they're thinking something of parallel. Only the hardware guys were thinking running something in parallel. Now the workload, the way the workload has to be distributed or scheduled into the NPU, TPU, or VPU, there needs to be a huge amount of DMAs, shared memories, and the way the memories are to be coordinated in such a way that they don't corrupt each other. So those are going to be very challenging. And how this system software going to be changed in that is also be very challenging. For example, now I had a typical classic software. I used to have a GCC framework. I used to compile it and I used to throw an Xcode into a memory. So that was the end of story. Now I need to take a same software. I need to first convert it into an intermediate representation, and recursively I need to run an MLIR or a CUDA framework. So CUDA is like super good in that. But for other guys out there, the MLIR is going to be the main thing. That's what it looks like. And what MLIR is going to do is it's going to recursively see, okay, what is the hardware that I have in this chip, and how am I going to use that hardware to run all my parallel tasks? And that needs to schedule in such a way that it doesn't come and schedule it into the normal housekeeping CPU. Whatever has to be outsourced to the TPU or the VPU has to go there and sit there and to be executed there. So system software is going to become very complex, and the peak utilization of system software is going to be very challenging. Why? Because second thing is like if you see the CUDA framework, right? I was seeing a report from AWS recently. If you see any AI workload, the amount of workload being run by the x86, the Intel or AMD, mostly now it is Intel, right? Because of the legacy software support. It is hardly 5% or 2%. It's going as low as 2%. 98% of the workload is running on the GPU. Same thing has to happen on the edge devices. So now AI is going to transit to a custom silicon, custom solution, which is going to run on the edge. And there we don't have a GPU, we don't have a CUDA framework, and everywhere NVIDIA cannot come and do business. So someone has to do this whole system architecture circus, right? Now Tenstorrent is doing that. Their 10.6 cores, I was seeing this interview by Jim Keller a few months back, and they are totally on the RISC-V framework, and they bought the sci-fi RISC-V framework, and they are adding a lot of VPU stacks on the 10.6. And the recent solution they have the black hole, which is 745 TOPS, which is very good. The amount of TOPS it's providing is better than NVIDIA, but they are struggling with the software stack, and they're struggling with the system architecture. How do they make sure that it is efficiently run and it is efficiently portable as good as NVIDIA, right? So there the system software challenges are seen. And what they are trying to do is they are going back to the bare metal, right? Again, they're going back to the bare metal because they don't know how to run a system software using a Linux kernel. So this is going to go ground up. It's going to go through a lot of refresh, and there's a lot of work, a lot of jobs going to be created in this area. Even the customer solutions are not going to be easy. That's what I see as an answer for that.
Thanks, Rahul. So looks like a lot of cross disciplinary or cross skill set, whether it's a hardware, software, data science. The individual need to get awareness and get enabled on these sets of skill set as we look forward to the future of AI-based semiconductor now. I have interesting questions on the flows and methodologies. Raja, if I can ask you this question, so how do you see the EDAs, flows, methodologies, and Synopsys, and of course your peer, they have a major role to play because you guys will be the enablers. So how do you see these roles, the folks who are actually working and enabling these flows, methodologies, how do you see these roles are going to evolve?
Yeah, so since there is some echo, I could not hear you properly, but still, I think I have a outline of your question. I don't know whether you're talking about the roadmap or
what were the roles for the EDAs and flows and methodologies?
Yeah.
Because you have great experience in Synopsys, so if you can give us some insight, how do you see this is going to transform?
both in verification as well as in design sign-off. When it comes to sign-off, both in verification and design implementation sign-off, we have AI-based solutions, and it's still evolving, and it has a long way to go. That's what I see. It is, for me, at least in my personal opinion, it is still in nascent stage in many aspects, but it may accelerate in the coming months. That's my perception about this. I'm not sure whether I answered your question because it was
yes, to a certain extent, yes. And as we heard, the leaders, they did mention by 2027, right? The genetic AI will be in a place to take care of almost 90% of complex chip design. So
yeah, we can expect that to happen.
That appears to be real, right?
Yes.
That appears to be real now. Yeah.
Even today, it's happening to a large extent, but we still, at least my wish is to see much more acceleration when it comes to both fronts.
Sure. Thank you, Raja. And the most interesting topic is on for Nitin yourself, so when you look at, I'm sure that a lot in the audience will be interested and, seeing themselves as a future entrepreneur, right? So how do you see, what are the qualities and what are the must-to-have skill set these individuals as a future leads and future entrepreneur, they should possess, to be a successful entrepreneur, as part of the semi services or semi product development?
Yeah, very important and relevant questions. Thank you. So most of the engineers who are basically coming from the universities, having theoretical knowledge, I must appreciate institute like Maven, who are basically giving and closing the gap between practical and theory. Okay, so how to the gap between industry and university is getting closed by training institutes like Maven Silicon. So very important role you are playing over here, and most of the engineers who are learning design, verification, physical design, front end, back end, they are basically getting trained in fundamentals which can be applied practically over here. And while doing that, everyone must be confused ki I am learning design, I am learning verification, but where does my role I am playing in terms of AI? Okay, how do I catch the basics of AI, how I will use AI and all. So it is very important that you define yourself what you can do. The common sense prevails over here, whether you are a designer, you are a verification engineer, or anything else, or you can simply good in making scripts. Okay, so you define yourself what exactly you can do and create a differentiation over here. First, that step is equally important over here, and then once the basics are clear, basics of design, basics of verification are clear, how efficiently using AI you can complete design, you can architect, you can basically design a particular electronic circuit, that and how you can efficiently create that design using historical data is the AI capability you can bring in basically. So the efficient usage of historical design or verification data in your current design and verification cycle, that is the role you will play as a beginner in AI driven chip design. Am I answering your question?
Entrepreneurship, like, so
Okay.
what are the few
Yeah.
things they can focus on, like,
Yeah.
because
Before taking your question, I just wanted to tell them how, where, because everyone must be confused. I am a beginner in chip design industry, and how I will use AI and where I will use AI. So I made it clear. Now, when you are entering as a engineer in chip design or any industry, everyone will have a dream of becoming entrepreneur. So keeping your eyes and aspirations in line with the roadmap, you should able to work with and interact with intelligent people in the industry, industrial subject matter experts. Okay, you are coming to office, doing work and going back home is not the way to learn something. Okay, you should interact, working, the concept working from home in ongoing generation is a worst concept. Okay, in this concept you can't interact with your team members, you can't learn new things. So learning new things, applying applying in the practical life, and then having a network of people around you will take you to the dream of become entrepreneur. Okay, so it is very important that you should have courage, you should have dream, and you should have network and the knowledge to become a successful entrepreneur.
thank you, Nitin. Before we conclude, let me ask a common question to all of you, and I'm sure that all the audiences and rest of the leaders will be interested in hearing from you. Uh, if you do a time travel back, in your college days, in your school days, right? So what are the few things would you focus to stay relevant, right? Or what are the few things you will ensure you build to stay relevant in the current era of AI-driven semiconductor? Let me start with Ravi, yourself this time.
Okay. So I think when I see myself 15 years back and currently whatever the AIs are doing, we were also used to do the same thing, like the auto generations of the test bench and all through the XLS scripts and all these things. So I think we need to shift our skill set, not shift, I'll say that add on the things like I thought like I should be like expert in the Python or the Perl or anything scripting, which is the backbone of basically all this AI, I can say, right? So that's a very good learning things that apart from the SV, UVMs and all, because I have learned all SV, UVM, EVCs, all the old days, right? But we never thought about the learning of the scriptings and all. So I think that is the one thing which I would like to like see if like I can go back to the 15 years back.
Sure. Thank you, Ravi. How about you, Raja?
I'm not sure if we have to go back. Even now, we have a lot of things to learn, like prompt engineering to whatnot. Even we can learn Python now, even now. And I keep seeing some ads that says like you should not learn Python manually, and there is Gen AI that can help. So yeah, we still have a lot of opportunity to learn, and then yeah, we just need to follow that faster, smarter. I forgot the last word.
Sure.
It was very catching. Yeah, we should adopt that when it comes to learning.
Sure. How about you, Rahul?
Yeah, well, the concept of time machine makes me think a lot of things. So I would have been very rich by now.
And in fact, every one of us want to really go back in time, like and make a different career choice if that would have helped us to better enable ourselves in this AI era. Right? Yeah. Please go ahead. Sorry to this.
Just as a joke, like if there was a time machine, I would have gone back in time, learned graphics, and joined Nvidia as a first company and just stayed there without selling any stocks. So, anyways, from the learning perspective, what I feel is if there was a time machine, if we go back in time, I think we neglected computer science a lot. Myself, I was a computer science grad when I entered college, and I took a change of branch into electronics because back in my days, electronics used to be the topmost premium branch. But then in computer science, I feel like with the introduction of UVM, we saw, okay, now we need to learn object-oriented programming. And then we went into, usage of Python, usage of Perl, usage of automation. So I feel somewhere for electronic engineers who primarily run VLSI industry, right? The neglect of computer science cannot be done anymore. So the computer science becomes very important, and we need to learn layer by layer, tool chain after tool chain, software stack after software stack, and what it means, how to use it efficiently. So a simple example is now, like I told about system software, right? So how do I test it? So there is a PyTorch library, there is a AI application. Below that, there is a Onyx platform, Open Neural Network Exchange. On below that, whatever transformer I have, like CNN transformer or Hugging Face transformer, whatever transformer I have, and then I have an intermediate representation. Then I have a intermediate compiled code, and then I have the final code. So how this whole process is to be tested, I think these are going to be the pain point. And how do we use any AI ecosystem efficiently will be a very big pain point for electronics engineers, because I am seeing, I have friends in software area, and the way they are using agentic AI is next level. They are at least 4 years ahead of us, right? So I think if we go back in time, maybe now it's still not late. I think going forward, learning the software perspective becomes very important. Yeah, so
Thank you.
that's it from my side.
Nitin, how about you? If you had to go back in time, what are the few skills that you would have looked at to anticipate this AI era?
Yeah, I think if I would have gone back, I would have learned more scripting skills. Scripting is most important in current AI age, and how the historical data can be used through script for assertions, for architecture building, the reuse of various components, and for the efficient coding, efficient regressions will be important. So yes, I would focus more on my scripting skills.
How about you, Pradeep, if I can conclude?
Yeah, so just on the side note, I would have joined Maven Silicon basically to acquire the skills. Okay, so yeah, just to back to the serious topic, I would have more focused on timing concepts because core is where actually you have to stick to. I still stick to my core basically and then worked on it. Okay, that will take a lot of mileage from me. Okay, thank you.
Sure, thank you, Pradeep. So thanks a lot, leader. It's a very insightful, short but very focused discussion we had. And if you can summarize on behalf of all of us, the acceptance, adaptation, and transformation is key. It's must, right? So I understand it's all about how the role will evolve. But I believe as long as all of us are willing to take that, change, transform ourselves, look beyond the traditional way of doing things, embrace AI, take the best out of it, use it in our day-to-day work, and make ourselves more efficient. I believe that's how I would like to summarize this discussion. Thanks a lot, everyone, for your time. Thanks a lot, everyone, for your time.